All right, so we get a collision here between these, and that's going to weaken these chemical bonds. These are covalent chemical bonds here. Also, we do, in order to help break these chemical bonds, we are going to need to spark this or run an electrical current through the container, and that will help break these bonds, and then the atoms are going to rearrange and produce product over here. Now notice we're dealing with, we can think of this as two molecules of hydrogen right here reacting with one molecule of oxygen over here, producing two molecules of water. But dealing in molecules is impossible. These are so small, undetectable in terms of their mass and that sort of thing. This one molecule is way too small to get any sort of information on whether these reacted. So what we typically do in chemistry, we're going to deal, instead of molecules, we deal in moles. So now we're going to have, let's think of these now in terms of 2 moles of hydrogen gas are going to combine with 1 mole of oxygen gas, making 2 moles of water as a product. So we typically think of these balanced stoichiometric coefficients, these mole ratios, as mole quantities. So 2 moles react with 1 mole to produce 2 moles of product here. Now, presto changeo, we have sparked this, this container here. The container, think of it as in white. And we have now formed new chemical bonds. Now we have the oxygen joining up with the hydrogen, and again, there's the covalent bonds. And notice that matter has been conserved. We still have the same number of hydrogen atoms that we had over here. We still have the same number of oxygen atoms that we had over here. Again, remember that the product here is moving around. Let's just assume it's in gas form, and let's talk about 2 moles of product being produced from 1 mole of oxygen gas to 2 moles of oxygen gas. These were consumed. They got used up. These 2 moles of water have been produced. So instead of 2 molecules here, you could think of 2 moles of water, so it's 6.02 times 10 to the 23rd times 2 to get you the total number of molecules that are produced as a product here. Well, it looks like in this chemical reaction, we do not have any excess reactant left over. So because we had 1 molecule here combining with 2 molecules here, neither of these reactants was left over. So in this case, we have only product in this container. All product and nothing left over. Let's look at another example now. Now we have 2 molecules here, or we could call it 2 moles that we're reacting here, that are in the container, 2 moles of the oxygen gas, and we're combining that with 2 moles of the hydrogen gas. So again, this here is representing the balanced equation. So these represent the balanced equation. This represents how much we added. We don't have to add 1 mole here. In fact, here we have, this represents 2 moles. We could add 15 moles, 30 moles. Here we could have 2 moles or 0.5 moles. We can add any amount here, but they're always going to react in this ratio. You're always going to get 2 moles here reacting with 1 mole to produce 2 moles of product here. So let's take a look here. This is telling me that 2 moles here are going to react with 1. So here are 2 moles. Here, this represents 1 mole, or you could think about it as 1 molecule. And this will react with this. So now I've labeled the limiting reactant. Notice all the limiting reactant has been used up. So we have no more. Where did it go? Well, there it is. There's an oxygen. That's one of the oxygen out of the 2 there. There's another oxygen out of the 2. It's now part of the product. We still have hydrogen gas, a molecule, left over. All of these are buzzing around. Let's assume these are all gases. And they're all buzzing around in this, this white container here with a high amount of molecular motion and kinetic energy. But again, oxygen was limiting. That ends up as product, and we have excess hydrogen. Now we've got a new situation. We have, let's deal with this in terms of molecules here. So we have 1 molecule of O2, and now we have 3 molecules, count them, of hydrogen gas. When these chemically react with each other, we are going to get the chemical reaction where 1 molecule here will combine with a molecule here and a molecule here to make water. After the reaction's complete, we produced, this would be our product here, and it looks like we have 2 moles of product. Now again, it just happens that the 2 moles of product equals the molar ratio here. But again, it could have been more or less than that. Regardless of how much product, it's always going to follow the reactant and the products are always going to follow a 2 to 1 to 2 molar ratio. Anyway, here's our product, and notice there's oxygen here, which is now in excess. So this is the oxygen that's left over, and it looks like now I erase this. This is excess reactant here, so I'm not going to rewrite it, but that is oxygen's in excess. And it looks like all the hydrogen's gone. It's used up completely. Remember, the hydrogen is the small white atoms. So all that's used up, and it's now part of this product. All right, let's take a look at a different reaction with different stoichiometric coefficients. Here we have hydrogen gas plus nitrogen gas yields NH3, which is ammonia. It is a balanced reaction, and we have gases in all 3 instances, gas reactants and gas products. So this is balanced. So we've got our balanced equation here, but we're going to add these. Let's just think of these in terms of molecules. We're going to add this many molecules of H2, combine it with 2 molecules of N2. Notice the N2 has larger atoms compared to the H2 just based on their atomic size. So that's what we have here. We have this in a container at a certain temperature. Initially, we have 0 product produced. But let's see how these are going to react now. These are going to react following the stoichiometric coefficient. So for every 1 molecule here, we're going to consume 3 molecules here, and we're going to produce 2 molecules here. We don't have 1 molecule, though. We have 2. So let's see what's going to happen here when we get the reaction. So for every one molecule here, we're going to react with 3 molecules of the hydrogen. So these molecules will react to make NH3. Then we have another one here. So for every one, we're going to react with these. So after the reaction has proceeded to completion, I've got product here. That's my NH3. Notice I've got these molecules that were produced. And notice there's 2 molecules of hydrogen that were left over. Look at again how they reacted. So for every 1 molecule here, you're going to need 3. So it's reacting in a 1-to-3 ratio. And then here's another molecule. So we're going to need 3 of these to make our product here. And here's the molecules of hydrogen that are left over. Notice all of these get used up. And they're all going to be over here as product. So again, there's our product. We had 2 molecules of nitrogen, and they're diatomic. So now we have 4 individual nitrogen. So that adds up. And there's our excess. In this example, nitrogen gas was limiting. It ran out. So there's no more in the container. In the container, however, we do have excess amounts of hydrogen because it's simply there was no nitrogen left to react with.
He went into the jungle where all the monkeys throw nuts.
If I stay here, I'll go nuts.
Hooray, hooray, hooray.